Graphing linear inequalities. Yeah, that's what it says. I know it's hard to read, but I'm gonna go right till the end, okay? So example, if you see 4x plus, I'm gonna come by and pick up those ACs in a bit, okay? If you see 4x plus 5y is equal to 20, that would be an equation, okay? Let's put it right next to it and say 4x plus 5y is greater than or equal to 20. This is an inequality. They're both linear, and they do the exact same thing. They work with inequalities in pre-cal as well, pre-cal 11. Okay. An inequality does not only deal with the points on the line, but with all the points found either above or below the line. We indicate this by shading the area or pane lying above or below the boundary line. Boundary line is probably important. I'm going to scroll up a bit, okay? There we go. Did you catch up? Sure. Is that good? Okay. I'll let you catch up a bit. I'll read it again here. Are we here? Are we right about here? An inequality does not only deal with the points on the line, but with all the points found either above or below the line. We indicate this by shading the area or pane, so a pane is an area, right? Lying above, below the boundary line. That's what that paragraph is saying. Okay. The inequality negative 2x. So they almost look like linear like equations, except for they always have the less than or greater than, right? The inequality negative 2x plus 4y is less than 16 has a boundary line of, and here it is, negative 2x. It's the same one, except for we're going to replace the inequality with equal sign, right? So we have, this is the inequality, which has a boundary line, which is really just the linear equation with an equal sign. Okay. Shading. One second here. Can I add something here to this? The inequality here has a boundary line of this. Which splits the coordinate plane in two. Okay, that's what I wanted to add there. I think I need to make my writing a little bigger, right? I will do that. So there's shading, something that I refer to regular shading. Shade true region, or the pane. Okay, and then there's reverse shading. You shade false region or pane. I would like you to box this in because this is going to be an ongoing. So we're going to today start with regular shading, but then I'm going to switch over to reverse shading, okay? And I'll make a little note. Textbook always uses regular. Just so you know, it only uses regular shading, so, but it will not change how to find the answer at all. So we'll just do a quick little, if I asked you to go regular shading versus reverse, and we're going to graph the exact same, we're going to do the exact same graph back to back. And I don't want you to stress over how nice this graph looks, okay? That's not the point. Just have them side by side. Let's make a grid like this. Just a small one. I'm going to use a different color. You don't have to. But let's try to copy the same one. So let's say we have a line going like this. Let's transfer that same line over and just copy it. So as you can tell, we still have lines, and they are called, this is the boundary. So every graph will have a boundary, right? So just label them boundary. Later on, we'll have an equation right there. So let's say for both of these lines, the true section is above, and so therefore the false is below the line. And we do the same thing here, true and false. Just for now, trust me. Okay? For now, you just have to trust me. So when you have an inequality, folks, the true and the false region do not change. Once you figure out which ones they are, they do not change, regardless of shading. But if you're using regular shading, you would say, hey, this is the true pane. Remember, it splits, the boundary splits this in two halves. We would shade just lightly the true region. Okay? See coloring within the lines. You thought it'd never come back, right? Kindergarten comes back, right? There you go. So the true region is shaded. If I'm asking you to use reverse, we're going to do the opposite. We're going to shade the false region, right? So that's, but I just want you to know that, right, true is still true, right? Like the true region didn't change, it's just the one we shaded changed. And the reason being why we're going to use reverse shading is because once you do a system, it gets really messy. And so if you do reverse, the solution is going to be clear, not shaded at all. So that's why I'm doing that. And you will see later on, it'll be a lot easier to work with. So I already give you the disclaimer, right? Okay. I will just give you a little, we're going to do, go ahead. When multiplying or dividing an inequality by a negative, comma, the inequality symbol flips. This is very, very important because some students forget about it. So I would actually just highlight that whole thing or make it very visible when you go through your notes and you review. When multiplying or dividing an inequality by a negative, the inequality symbol flips. And this is the reasoning behind it. I will show you a very, very simple basic example. So let's say you have 2 and 5. Which one is greater between the two? 5, right? So you would do this, correct? If you take that and you multiply this side by, let's say, -1, and this side by -1, we get, it's the same as an equation. If you multiply both sides by the same, you're not affecting it, actually. You're changing the way it looks. -1 times 2 is -2, -5, right? Which one is greater now? Yeah. See how it's now pointing the other direction, right? For the statement to remain true, you have to flip it. You have to do that yourselves. Like the calculator won't catch it. Nobody will. Like you have to think of that. So the same thing goes if you divide, right? So this is just an example to illustrate, right? What should I do here? Flip. right? So we flipped it the other way. All right, and so that's just a disclaimer. So we're gonna do graph the following. If you have dashed versus solid, boundaries, right? If you have this or this, it's dashed. If you have less than or equal to or greater than or equal to, it's going to be solid. So it's actually something that's going to be quite at first annoying to you, but I'm going to be picky on that like right away. Did you get that right? Okay, so we're going to graph now. Now we're ready to graph now that I told you that. Graph the following inequalities. And I'm going to tell you, use regular shading. Today, I actually will always tell you what kind of shading, but I will tell you how you know for sure in case I forget. Graph the following inequalities. So we're going to do that right now. So we have first, we have 4x minus 5y is greater than 10. Okay. So what I will ask you to do first and foremost is we're going to find the x and the y-intercepts just like I've been doing so far, but I want you to do them by hand. It's going to be a lot quicker than using our calculator. So basically, look at this. This is an inequality. I'm going to now take the equation that would mark the boundary of this inequality and write it down. 4x minus 5y is equal to 10. So forget about the inequality for now. And when it's x-intercept, then we know that the y is equal to 0, correct? So we plug that in. 4x minus 5 times 0 is equal to 10. So it's 4x is really equal to 10. Divide both of them by 4. X is equal to 2.5. So the x-intercept is 2.50, right? The y-intercept will do the same thing. Because this is your first example, I'm actually writing it out completely. Later on, we won't be doing that. The x is equal to 0, right, at the y-intercept. So it's 4 times 0 minus 5y is equal to 10. Negative 5y is equal to 10. Divide both of them by negative 5. Y is equal to negative 2. So it's 0, negative 2. Box that in, keep it aside. So these are the intercepts that we're going to use to graph our boundary line, right? Boundary line right here, okay? So we're going to use that to find our boundary line. So this would be step number 1, so to speak. Before I graph it, do this first. And I will give you more detailed notes on this, but I need you to practice right away how to just graph 1. Second step is rewrite. And it works the same way as your equation would. So 4x minus 5y is greater than 10. You got that part? The 4x comes over, subtracting, right? So you have negative 5y No equal sign, just copy what is already there. The 4x comes over subtracting, the 10 is already there. And what are we going to do now? Divide by -5. Oh, wait a minute. Did you say negative, Mr. Dixon? Let me see here. When multiplying or dividing an inequality by negative, the inequality symbol flips. Don't forget that. So I'm going to be kind of silly about it now so you don't forget, okay? So divide by -5, divide by -5, and we go y, flip that the other way. So it's pointing that way, now it's going to be pointing that way. 4 over 5x minus 2. Okay, so you've rewritten it. And I'll just add something here, of course, because we need to make sure we remember, right? Flip inequality, right? Flip inequality. Sorry, you can't see that, but I just wrote down flip inequality. And if y, so basically if you notice that the y term is negative, you know you're going to have to flip the inequality, basically, because you're going to have to divide by negative to turn it into just y, right? All right, so that's that. So now we go ahead and try to graph this. So I'm going to graph this down here. I'm not going to use a whole lot of room, so don't worry about that. I put the x there, the y there, right? So x, y, good. My scale, my numbers are very small, so I'm not too worried about it. So I'm just going to go up by 1. 5 that way. 1, 2, 3, 4, 5. If anything, next year or whatever, if you take applied 40S, you're going to be really good at graphing by the time you're done with me. Okay, so you're going to be excellent at that. 2.5, 0 is right there. 0, -2 is right here. I'm using the x-intercepts, right? So I want to graph my line, but because of this, right, that tells me that it's dashed boundary. Okay, because there's no equal, it's just less than, there's no equal. So when you're coming over with your ruler and you want to make a dashed line, just make sure, right, just make sure I can clearly tell. Some students forget, and then it's easy to repair. You just go eraser and just erase with a little bit of space in between, right? So that is your boundary line. And we go y is less than 4 over 5x minus 2. Labeling. And this is the hardest part right now. Maybe this is the newest thing right now. Remember I said we're going to shade? Because this is inequality. We're not talking about just the line. We're talking about one of those panes is going to have to be shaded. Okay? So shading, I will do that here. So what I do is pick test point. And I'm going to usually pick 0, 0 because it's the easiest point to pick. Origin, right? The origin is your friend. It's very easy to run it through your equation. Where is 0, 0, folks? Right here, correct? And I know it's a bit silly, but it's right here. Is it above or below the line? It's above. Okay, so keep that in mind. We're going to see if 0, 0 is true or false when we plug it in. If 0, 0 is true, that means that all the points above the line are going to be true. If 0, 0 is false, that means that this whole region is false. That's what we're doing right now. And so I'm picking that one, noting that it's above the line. So I'm going to take the original there, 4x minus 5y, just because I find it easier to work with, not that the other one is wrong. So I'm going to plug in 4 times 0 minus 5 times 0 is greater than 10. That is 0 minus 0, which is what? 0, right? What do I know about this statement? It's false. So you pick the point, it's above the line, you ran it through, hold on, and I will make a statement here because I know you're going to sit down and be like, how did he do that again, right? I will say this, since 0, 0 is above the line, right? The whole pane above the line. Hold on one sec. It's one of those over there. Okay. Yeah. The whole pane above the line will be false. Highlight this, right? That we determined that the statement was false, and therefore, right, everything above will be false as well. So before you even shade, let's go to our graph and just write false here. And if one side is false, then the other side is true. Yeah, it is, by definition, it is the case. If you don't believe me, we could pick any point in here, run it through our inequality, and it should be true, right? This statement will be true. Okay, so we're using regular shading, which means we're shading the true region. So come over here. This is what I normally do. I put my ruler right up against the line and then just shade. That way you don't have to worry about going overboard. Hi there.
Question. Do you know if books like this exist for a living?
Let's make it scary. It's not that bad. Don't worry about it. It's nothing you can't handle. There you go. Always keep in mind, right? If it doesn't look the way you want it to look, you can always use the algebraic rules to just move stuff over and, right, distribute. Like, you don't have to be scared of that. Okay? Okay, so if I asked you to graph something like this, I would probably say, let's clean it up a little bit. So I will distribute this. Okay, so you got 2x minus 5y is less than or equal to 3x plus 5. Anything wrong with that? 3 times 5 is 15, right? Okay, I was waiting and nobody caught me. Anyways, I know you were thinking, what? But there it is, right? So you have that. Watch what I'm going to do now. This seems to be a little bit counterintuitive, but I'm going to have the x and the y here and just a number there. It's a little bit easier to find the x and the y intercepts that way. You don't have to. So it's 2x minus 3x minus 5y. Do not flip the sign when you're just bringing items over. The flipping of the sign happens towards the end when you're isolating y. 2x minus 3x is negative x minus 5y is 15. This is the standard form, right? I don't know if you remember from my APR. There was the general, there was the standard, there was the slope intercept, there's a slope point, right? Point slope. And let's find, you don't have to worry about the names. Not in this course, you'll be fine. I'm just letting you know that it's all connected. What we do is still connected with what you did in IPR. X-intercept, let the y equal to 0. So it's really negative x is equal to 15, right? Because the y term goes to 0. Divide both sides by negative 1. You can't just let it be negative, right? So you're really just turning your 15 to a negative. So it's negative 15, 0. See, that'd be there. We have to be careful with our scale, right? We're going to have to be creative there. Y-intercept, x is equal to 0. Divide both sides by negative 5. Y is equal to negative 3. So it's 0, negative 3, no problems there. Now we have everything we need to graph our boundary line. I consider this my first step. You don't have to do it in the same order, but I tend to do it that way. Second step, watch how I'm going back to the inequality now. I'm just going to bring the x over to the other side. Negative x, so that's x positive plus 15. Divide everything by negative 5. Oh, warning, warning. This should be warning here. What's happening? We're dividing, right? Dividing by a negative. Flip, right? Flip the sign or symbol, right? So y is greater than or equal to, and this is a bit weird here, but I'm going to go negative 1/5 x minus 3, and that's my rewritten. And the forgetting to flip the sign is a whole mark, okay, a full mark deduction, so you have to be careful. Now, let's start our graph. So I'm going to go, don't make it too big, okay? I will make my x-axis a little bit longer. Like that, maybe. You should be able to do this without, oh, graphing paper, sorry, you're not seeing that. But there's my grid. I need to fit in negative 15, so I'm going to be creative. I'm going to go negative 5, negative 10, as long as it's equally spaced out. As long as you're not spaced out right now. Okay, 5, 10, 15. 1, 2, 3, 4, 5. So I'm just going to go negative 5 here. See that? Some of you might think, wait a minute, how can you go by 1 on your y and by 5s on your x? That's okay. But you cannot change within the axes. Once you pick a scale, you stick with it. So negative 15, 0 is right here. 0, negative 3 is right there. Solid or dashed? Solid, right? So make your line. Don't be scared to extend past. I'm going to label it right away. Now I need to figure out the shading. So test point, 0, 0. Where is 0, 0? Above or below the line? Okay, so we go, I'm going to go, you can pick any one, but I'm going to pick this one here. Negative 0 minus 5 times 0 is supposed to be less than or equal to 15. That 0 is less than or equal to 15. Is that true? It is. It is less. It's saying it has to be less or equal to. That's what the statement is saying. One of them has to be true, and it is less. So this is true. Okay? So follow me here. Since 0, 0 is true, everything above the line is true. So you can go true and false, and that never changes. Once you determine that, regardless of the shading, it does not change. True remains true. Okay? So we're gonna shade. If you don't shade, it's not an inequality. You actually are just thinking it's a linear equation. You need to shade. So basically what you're saying is all the points here are gonna satisfy that inequality and make it true. Okay? Hold on. I know. Page 1 in the booklet, which I'm gonna give you.